Hello, in this video I'll be going through the multiple choice study guide for the final. So the first question asks us to test for symmetry with respect to each axis into the origin. So if you recall, this was from our very first chapter P, I think. And the general procedure is that we have to first plug in negative x to test for symmetry with respect to the y-axis. Let me write it down. So first, plug in negative x for x, and then if the function remains the same, meaning that you can simplify it to the original, then this means that it's symmetric with respect to the y-axis. Symmetric with respect to the y-axis. Okay, right? Because, if x is the same as negative x, then that means it's a reflection across the y-axis. You can think about it graphically. Second, we can also plug in y, or negative y for y, and if this is, if the function remains the same, then this means that it's symmetric with respect to the x-axis. And then finally, we have to test for symmetry with respect to the origin. And for that, we plug in x to negative x and also y to negative y. And if this is, if it remains the same function, then that tells us that it's symmetric with respect to the origin. All right, so for instance, in this question, the first thing we would try is we would plug in negative x. So we would do y equals negative x squared plus 7 over negative x. And then we'll try to simplify that and see if we get the original. If we simplify this, right, the top negative x squared is just x squared. And the bottom is negative x. So clearly this is not the same as the original. All right, there's a negative x instead of a positive x in the denominator. And so that tells us that this function is not symmetric with respect to the y-axis. Second, we can plug in negative y. That would give us negative y equals x squared plus 7 over x. And then, we could simplify this just by multiplying both sides by negative 1. And clearly we don't have the same thing as the original. So once again, we don't have this kind of symmetry with respect to, in this case, the x-axis. And third and finally, we plug in both negative x and negative y. And what do we get? Turns out if we simplify this, we actually are going to get the original. And so we know that based on this test, we do have symmetry with respect to the origin. And so that means our answer is choice A. Next, we were asked to find an equation that passes through, of a line that passes through a point with a given slope. So that tells us we should use point-slope form. So recall the formula here, where x1, y1 is the point, and m is the slope. So we just plug in the values here. Y minus negative 7 equals negative 3 halves times x minus negative 9. And so that's y plus 7 equals negative 3 halves x plus 9, or y plus 7 equals negative 3 halves x minus 27 over 2, which means y equals negative 3 halves x minus, if you do the math, that's minus 41 over 2 if you subtract 7 from both sides. So the answer is B. Next, write an equation of a line that passes through a point and is normal to the line x plus y equals 2. Okay, remember that normal means perpendicular. All right, and so we need to first find the slope of this line, and then find the perpendicular slope, which is a negative reciprocal, right? And then that's going to be the slope of our new line. So to find the slope of the original equation, we're going to write it in slope-intercept form, right? Y equals mx plus b. And to do that, we're going to move the x to the right-hand side, which gives us negative x plus 2. Y equals mx plus b. So the slope is m equals negative 1. All right, and so because the slope of the new line should be the negative reciprocal, the new slope is going to be 1 over negative 1 equals negative 1. Sorry, negative reciprocal means it should be negative 1 over negative 1, which is positive 1, right? And so that tells us that we're looking for a line with slope positive 1 that goes through negative 6, 5. And so we're going to plug those values into our slope-intercept form. So m times x minus x1 is 1 times x plus 6. So the answer is y equals x plus 11. Okay, looks like I need to write it in a different format to get the right choice. So I'm going to move everything to the left-hand side, I guess. And that will give me negative x plus y minus 11 equals 0. All right, still nothing matches, so I'm going to multiply both sides by negative 1, get y minus 11 plus, x minus y plus 11 equals 0. So that's choice A. All right, question 4, domain and range of this function. So for the domain, the only restriction is that the denominator can't be 0, right? And so that tells us that x can't be negative 1. In terms of the range, the only restriction is that this fraction can never equal 0, right? And that's because any fraction with a numerator that is non-zero is, right, it can't be 0 no matter how big the denominator is. It's always going to approach 0, but it will never reach 0. And so the range h of x can't equal 0. And it looks like the only choice that matches that is B. All right, remember that the square brackets here, those represent inclusive ends of an interval. So that would include negative 1, so that's not right. We're looking for the round parentheses because those exclude negative 1. And as you guys remember, this U means a union of two sets. All right, question 5. We're given a piecewise function. So what this means is that given the condition x is less than 0, so if x is less than 0, then we should evaluate the function using x squared minus 2. But if x is greater than or equal to 0, then we should evaluate it using 2x plus 1. So that's all we need to do here. If we want to calculate f of negative 3, that means we plug in x equals negative 3. Negative 3 is less than 0, so that's going to be negative 3 squared minus 2, which is 7. For f of negative 1, that means it's less than 0, so we'd use x squared minus 2. The answer is negative 1. All right, for f of 0, that means x equals 0, right? But if x equals 0, then that means it's greater than or equal to 0. And so we apply the 2x plus 1 to x. And so we do 2 times 0 plus 1, which is positive 1. And finally, f of 4 is 2 times 4 plus 1 equals 9. Next question, determine the quadrant in which theta lies. Well, if secant is greater than 0, in other words, secant is positive, that tells us that cosine also has to be positive. right? The reason is that cosine and secant are reciprocals of each other, so they always must have the same sign. And then similarly, if cotangent is negative, that means tangent is negative. Okay. Here you could use the all students take calculus thing, but I don't really like that, so I'm going to do it properly. If cosine is greater than 0, then that means on the unit circle, we're looking at an angle with the positive x coordinate, right? So that means x has to be greater than 0. On the other hand, if tangent is negative, that means that means y over x must be negative, right? On the unit circle, because tangent is sine over cosine. So y over x is negative, which tells us that x and y have different signs. And so therefore, if x is positive, then y must be negative, right? And so which quadrant is that? If x is positive and y is negative, we're in quadrant 4, so the answer is A. Next, find 2 solutions of this equation. Okay, we're just going to go to our unit circle. All right, if cosine is root 2 over 2, then that means on the unit circle, we should have an x coordinate of root 2 over 2, right? And so that's either this point or this point down here, right? And we know it has to be some multiple of pi over 4, or 45 degrees, because we have this root 2 over 2. And so the answer is going to be pi over 4 and 7 pi over 4, right? 7 pi over 4 is just 2 pi minus pi over 4. So that's how we get that. And so we would just write those as our answer. All right, and we're only looking for angles in this interval, so negative pi over 4 would be wrong. All right, if cosine is 3/8, how would we find cosecant? Well, we're going to draw a right triangle. You know, if cosine is 3/8, then on a triangle, assuming theta is between 0 degrees and 90 degrees, then that means that if this angle was theta, then adjacent over hypotenuse would have to be 3/8, right? So these are some possible side lengths. If cosine's theta, then the adjacent side could be 3, and the hypotenuse could be 8, if cosine theta is 3/8. By the Pythagorean theorem, that tells us that the remaining side is the square root of 64 minus 9, right? Which is square root 55. All right, so that tells us that cosecant theta, which is 1 over sine, or hypotenuse over the opposite side, would be 8 over 55, which technically you should rationalize, but it seems like the answer choice did not. That's choice E. Next, 9b. Or sorry, I said the answer. I meant to say question 9. Determine the following limit using the graph. So we're interested in the limit as x approaches 2 of this graph. All right, so we're looking at this graph as x gets closer and closer to 2, both from the right side and the left side, right? But the thing is, in order for a limit to exist, the graph has to approach the same value from both the right side and the left side. But the thing is, for this graph, as x approaches 2 from the right side, the function approaches infinity, whereas when it approaches 2 from the left side, it approaches negative infinity. That clearly doesn't match up, so the answer does not exist. All right, evaluate the limit sine 2x over x as x approaches 0. Clearly as you plug in x equals 0, the numerator and the denominator are both going to evaluate to 0, so you would have a 0 over 0. So that means we have to do some either simplification or use an identity to solve this. So we're going to use the fact that the limit as x approaches 0 of sine x over x equals 1, right? That's something we need to have memorized. But the problem is we can't directly use that because we have a 2x in the sign and not an x. And so here, the strategy is to make a substitution. So we're going to substitute y equals 2x, which means x equals y over 2, right? So we're going to make that substitution, x equals y over 2, and that's going to give us, all right, what is the limit as x approaches 0, or in this case, there will be y approaches 0, sine, what is 2x? 2x is y, so it's sine y now, over x, and x is y over 2, right? Now, if we simplify this a little bit, we could bring the 2 to the numerator because we have a fraction in the denominator. So we would have the limit as y approaches 0 of 2 sine y over y. Now, this is equal to 2 times the limit. Right? We can bring a constant out of a limit. That's always legal. But now this limit is simply equal to 1 by the formula that we know. And so the answer is 2 times 1, or 2. All right, so some important things to note. You have to have the correct notation. You have to be writing the limits for every single step until you finally make the substitution at the end. And also, make sure that you're not writing something like this. Make sure that you're not writing the limit equals something, right? That's wrong. That's bad notation. Wrong notation. The limit should never be alone. It always has to be accompanied by some kind of function within it on the right side of it. And so we always have the equal sign outside the limit on the left side. Let's keep going. Determine the following limit and show the graph f of x for your work. This is interesting. Okay, so if we were to graph this, we would have a parabola with a vertex at 0, 5. And so the graph would look like this. This is x and y. But we're going to have a hole here, right? Or sorry, no. The hole is at 1, 6. And there's going to be a discontinuity here because it's only x squared plus 5 when x is not equal to 1, right? So when x is equal to 1, y is equal to 6, there's going to be a hole at that point. And the real value of the function at x equals 1 is actually here at 1, 1. Right, so that's what the graph looks like. And so as x approaches 1, what does the function actually approach? Well, the answer is that, the function is actually, maybe let me zoom in a little bit here. The function is actually approaching the value 6, even though the function is not defined at the point x equals 1. As x approaches 1, f of x is going to approach 6, okay, right? Because 1 squared plus 5 is 6. And so the answer is A. Right? Remember that a limit is not the actual value of the function at that point. It's the value of the function as it approaches that point. And so the limit is going to be determined by x squared plus 5 and not the 1 down here. Next question, determine this limit if it exists. Well, here we're going to use the identity that we remember, which is that limit of x approaches 0 of 1 minus cosine x over x is equal to 0. So here, all we need to do is move the 6 to the outside of the limit, and we can use this identity. So the answer is just 6 times 0, which is 0, or C. Okay, next question. This limit is actually very easy to calculate because we simply need to plug in the value x equals 6. There are no issues with dividing by 0 or having a 0 over 0, so that's all we need to do here. We just plug it in. We don't need the limit notation because we're already substituting. So the answer is 6 over 36 plus 9, which is 6 over 45, or 2 over 15, which is choice C. Okay, next, find the limit. Well, as you can see, if we had plugged in x equals 1, then we would run into a 0 divided by 0 error, right? And so that tells us that we're going to need to do some simplification first. The good news is that this does simplify because the denominator factors as a difference of squares. And so we can rewrite the numerator as negative x minus 1. And the denominator becomes x minus 1 times x plus 1, right? That's a difference of squares factorization. And so that actually cancels out with the numerator. And we're just going to be left with negative 1 over x plus 1. And now that we've made this simplification, the 0 divided by 0 error goes away. And we can now substitute x equals 1. So we get negative 1 over 1 plus 1, which is 2. So the answer is negative half. Here, we don't need, to evaluate the limit, we just need to plug in x equals 7. So the answer is really just cosine 7 pi over 3. To evaluate 7 pi over 3, the cosine of that angle, we're going to use the fact that the cosine function has a period of 2 pi, right? On the unit circle, we're allowed to add or subtract 2 pi, or any multiple of 2 pi, from any angle, and we're going to return to the same exact angle, because the unit circle has a total radian measure of 2 pi. And so cosine 7 pi over 3 is also equal to cosine 7 pi over 3 minus 2 pi, which is 6 pi over 3, right? So cosine 7 pi over 3 minus 6 pi over 3 is pi over 3. And cosine pi over 3, we know that to be 1/2. Because that's the x-coordinate of that point there. So the answer is B. All right, here, find the limit. Well, if we plugged in x equals 5, then we would have a 0 in both the numerator and the denominator. So here we are going to have to use the strategy where we rationalize the numerator, right? What does it mean to rationalize the numerator? It means that we're going to multiply the numerator by its conjugate, and then we're going to hope that things cancel out. So, right, we have to keep writing these limits. Multiplying by the conjugate simply means that we are changing the subtraction into an addition. Or if it was an addition, we would change it to a subtraction, right? Don't forget these parentheses. So we're going to multiply top and bottom by square root x minus 1 plus 2, right? Changing the subtraction into addition. So if we simplify the numerator, that's a difference of squares, right? A minus b times a plus b is a squared minus b squared. And so the numerator becomes x minus 1 minus 2 squared, which is 4. And the denominator is, sorry, there's a typo there. It's x minus 5. The denominator becomes x minus 5 times square root of x minus 1 plus 2. All right, numerator, that simplifies as x minus 5, and stuff is going to cancel, right? So in the end, we have a limit as x approaches 5 of root x minus 1 plus 2. And so now we're able to just plug in x equals 5 because we don't have any divide by 0 errors. And so the answer is just 1 over square root 4 plus 2, which is 1/4. Answer is D. All right, determine the value of c so that the function is continuous on the entire real line. All right, what does continuous mean? Continuous simply means that there are no jumps. There are no gaps or jumps in a function. And so in order for this function to be continuous, that means that the value of the function at x equals 5, they basically have to match up as it approaches from the left and the right, right? If you imagine, a number line, this is x, and this is x at 5, the function has to meet up, right? There can't be any jumps. So it can't look like this. Can't look like that. They have to meet up. And so in order for the function to meet up on both the left and the right side, we have to have the same value when we plug in 5 to both pieces of this function. So that tells us that 5 minus 2 has to equal c times 5 minus 3. All right, so we have to get the same value when we plug in x equals 5 for both of these, both parts of the function. So that tells us that 3 equals 5c minus 3, or c equals 6/5. So the answer is B. All right, find the limit if it exists. This is very similar to before. We're going to have to rationalize the numerator. There's a slight difference in that x is approaching 4 from the left side, but that doesn't really change the problem, actually. So we're going to do that rationalizing the numerator process. So we're going to multiply the top and bottom by root x plus 2 over root x plus 2. In the numerator, that becomes x minus 4, right? X minus 2 squared, which is 4. And then the denominator is just that multiplication. And now this cancels out, right? So the answer is 1 over root 4 plus 2, which is 1/4. A. All right, determine the following limits given the graph. Okay, so for I, the limit as x approaches 4 from the right-hand side, right? So as x approaches 4 from the right-hand side, it looks like the function is going to approach the value 1. As it approaches from the, so we can write 1 here. As it approaches from the left-hand side, well, it looks like it reaches the same value, it's 1. And so because the limit is the same, approaching from both the left and the right-hand side, that tells us that the limit of x approaching 4, it does exist, right? So it would be 1 as well. If the left-hand limits and the right-hand limits were actually different, then this limit does not exist. But they're the same, and so we can just write the limit as 1. All right, and then it also asks, is the function continuous at x equals 4? The answer is no. There's a jump, right? There's a hole here, and then the value of the function actually jumps up to 2. So that's not continuous. It's 1, 1, 1, not continuous. 20, find the x values at which the function is not continuous. and which of these discontinuities are removable, right? So what is a removable discontinuity? That's a discontinuity that can be, right, removed by simply simplifying the function in some way. So typically that'll occur whenever we have a 0 over 0, because that discontinuity can be removed probably just by canceling out some factors. And so I'll show you. In this case, this function can be factored in the denominator. That's usually the first step for these questions. Factoring the denominator, what are two numbers that multiply to 18 and add to negative 11? It's going to be negative 9 and negative 2. So this factors as x minus 2 times x minus 9. All right, and so on the face of things, there are two discontinuities. There's a discontinuity at x equals 2, and also a discontinuity at x equals 9. Because whenever we have those, we're going to have a division by 0. That's not allowed. However, the x minus 2 discontinuity is removable. All right, x equals 2 is removable because you can cancel it out. All right, it cancels with the numerator. All right, so I'm allowed to write x minus 2 over x minus 2 times x minus 9. This can be simplified to 1 over x minus 9. So it is a removable discontinuity. So the answer would be C. All right, let f be a continuous function. Okay, this question is asking us about the intermediate value theorem. So let's just recap what that theorem is. So that theorem basically tells us if we have a function that is continuous on a certain interval, right? So let's say on a certain interval, this function is continuous. Maybe this is x equals a, and this is x equals b. And this value here is f of a, and this value here is f of b. The intermediate value theorem simply tells us that there must exist some x value where f of that x value crosses any intermediate value between those points, okay? So in this case, how would we graph it? Well, we have f of negative 2 is 3. And so if we were on a graph, where's negative 2? If this is negative 2 and this is 3, then f of negative 2 is at this point, and f of 1 is 6, right? So it's here, this is 1, and 6 is somewhere here, so we have that point there. Well, the intermediate value theorem simply states that for some value, in between 3 and 6, right? So some value here, and I think it's using 4 as our intermediate value. For some value there, the function must cross that value at some x value. And so no matter what the function looks like, as long as it's continuous, as long as the function is continuous, it has to cross, it has to cross y equals 4 somehow. I can't just jump over if it's continuous. It has to cross that line. It has to cross the line y equals 4. And so the answer would be f of c has to equal 4 for at least one x value, so at least one c between negative 2 and 1. So that would be D, okay? The reason it can't be f of c equals 0 is because 0 isn't actually in between 3 and 6, right? The function doesn't have to cross 0. The function doesn't ever have to equal 0 because, it could always stay above 0. It could equal 0. It could drop down to 0, but it doesn't have to. The only values that it has to equal are those intermediate values in between 3 and 6 here. All right, so if you're confused by these questions, just always try to graph the situation, see what's going on in the graph, And then the really tricky part about these questions is just interpreting the language here and seeing which choice is makes the most sense, right? But the intermediate value theorem itself is really just common sense, right? A function is continuous. It has to cross all the intermediate values in between those endpoints. That's common sense. Question 22, find all the vertical asymptotes of the graph. So remember, vertical asymptotes are always non-removable discontinuities, right? So in the previous question, we saw the difference between removable and non-removable discontinuities. Removable discontinuities, those always give us holes, but non-removable discontinuities give us vertical asymptotes. Okay, so just remember that. Right, you can think about it. A hole is super easy to remove. On a graph, right, if some function has a hole in it, that's super easy to kind of patch up and remove just by canceling out some factor, and it looks pretty much the same. But a vertical asymptote, right, that's impossible to remove. You would have to change the function entirely in order to get rid of it. So that's why those correspond to non-removable discontinuities. All right, so if we look at this function here, clearly we have two discontinuities. We have a discontinuity at x equals 0, because that would make x squared 0. And we also have a discontinuity at x equals 1. Right? And both are clearly non-removable because we can't cancel anything out with the numerator. So since both are non-removable, they're both vertical asymptotes, and the answer is C. All right, if g is the function defined by x to the fourth minus 5x, then what is the average rate of change on the certain interval? Well, average rate of change, okay, that's essentially the slope of the line that connects those endpoints on the interval. So it's going to be g of 3 minus g of 0 over 3 minus 0, right? In other words, it's kind of like final position minus initial position over final time minus initial time, right? You can kind of think about it like that. So that's what it means to have average rate of change. So graphically, if you had a function, doing some crazy stuff in the middle, but the average change is really just the slope of this line that connects those endpoints. So it's just rise over run for the endpoints, and you can ignore whatever happens in the middle. So the average rate of change, g of 3, is going to be 3 to the fourth minus 15, so that's 81 minus 15, minus g of 0, which is 0, that's all over 3. So 81 minus 15 over 3 is 27 minus 5, which is 22. Next question. Let f be defined by the function f of x equals this piecewise function, and which of the following statements are true? Okay, so let's look at each statement one by one and see if they're true. Okay, does the limit as x approaches 3 of f of x exist? Well, to see this, we need to determine whether there's a jump, right? Now, is there a jump? If there was a jump, then the two function values approaching from the left and the right would not be equal to each other, right? As we evaluate the function at x equals 3. And so are they equal to each other from the left and the right side? Well, x plus 2, which is 3 plus 2, is 5. But 4 times 3 minus 7, well, that's also 5, right? And so actually those different points, they actually do meet up, right? So we actually have this kind of situation here. So they meet up, and so that means the limit does exist because it's approaching the same value both from the left and the right-hand side. So we would say 1 is true. Okay, is 2 true? Is the function continuous at x equals 3? continuous simply means that there are no jumps or no holes. And of course, if they meet up on the left and right side, then it is continuous. So it is continuous. Now, is the function differentiable? Okay, in order for a function to be differentiable, it has to have the same derivative on the left side and the right side. All right, so we would have to evaluate the derivative on the left side and also the right side and see if they match up. If they don't match up, then the function is not differentiable. So we're going to calculate the derivative of the left side at x equals 3. And that's going to be 1. And on the right side, the derivative is actually going to be 4, right? And so these don't match up, right? They don't match up. They don't match, and so the function is actually not differentiable. So the answer is C. 1 and 2 are only true. All right, find an equation of the tangent line to the graph of the function at a certain point. So in order to find the equation, we need to have the slope. And to find the slope, we do the derivative. So the derivative using power rule is 2x plus 3. And so the derivative at which point? At x equals -1, right? The derivative at x equals -1 is going to be 2 times -1 plus 3, which is 1. And so that tells us that the slope is 1. The slope of the tangent line is 1. And so if we use our point slope form, we're going to have y minus 4 equals 1 times x minus -1, which is x plus 1. So y equals x plus 5. Okay. Next one. A particle's position is given by s of t equals t cubed minus 6t squared plus 9t minus 5. And we're looking for the acceleration. All right. So I might have forgotten to go over this in the lectures, but acceleration is just a second derivative of position with respect to time. And so that just means that we're taking the derivative of position twice. All right, and so the first derivative, we can do power rule here, 3t squared minus 12t plus 9. And then to find acceleration, okay, so this is velocity. Velocity is the first derivative. To find acceleration, we do another derivative. So s double prime of t, which is going to be 6t minus 12. All right, so that's the acceleration as a function of time. And so we just plug in t equals 4, and we get 6 times 4 minus 12, which is 12. The answer is E. All right, determine all values of x at which the graph of the function has a horizontal tangent. Well, to do this, we're going to take the derivative, because that's how we find the slope of the tangent. And in order for the tangent to be horizontal, the slope has to be 0, which means that the derivative has to be 0. So we find the derivative. We're going to get 4x cubed minus 256. And we're looking for those values of x such that the derivative is 0, because that would mean we have a horizontal tangent. So we set the derivative equal to 0, and we try to solve for x. So let's move the 256 to the other side. We can divide both sides by 4. 256 divided by 4 is 64. So that means x equals 4, because the cube root of 64 is 4. And so the graph of the function has a horizontal tangent only when x equals 4. The answer is D. Find the derivative of this function here. There are two different ways. I'll show you both ways. The first way, we can use quotient rule. This is the harder way, by the way. So we would take the derivative, and we do low d high minus high d low over low squared. So that's low d high, which is 6x to the 5th, minus high d low, which is 5x to the 4th. And then the denominator is x to the power of 10. So if we expand the numerator, we're going to get 6 times x to the power of 10, minus 5x to the power of 10 plus 40 x to the power of 4 over x to the power of 10, which is equal to x to the 10 minus 40 x to the fourth over x to the 10. And if we simplify this, split this up into two fractions, this is going to give us 1 minus 40 over x to the sixth. That's our answer. So the answer is choice C. Oh, made a mistake. This is supposed to be a plus, right? There's a plus sign there. So the answer is choice E. My bad. Okay, so that's the long way. The easier way is actually to simplify f of x before doing all that stuff. We can actually simplify this into two different fractions. So right, x to the power of 6 divided by x to the power of 5, that's just x. And then 8 over x to the fifth is just 8 to the power of x to the negative fifth. So that's a much easier way of writing it, and here we can directly use power rule. So that tells us that the derivative of f is going to be 1 plus 40 times x to the power of negative 6. And that is also choice E. So that took us 2 steps. All right, find an equation of the tangent line to the graph of f at the given point. All right, so in order to find the equation of a tangent line, we have to know the slope at x equals 2. We have to know the derivative at x equals 2. So to find the derivative, once again, there are two ways. Either we could first expand it, or we could use product rule. I'll show you product rule first. So for product rule, we're going to find the derivative of the first factor, leave the second factor alone, and then add with this time the first factor left alone, and then taking the derivative of the second factor. So that is going to be this. The derivative of x minus 4 is 1. So that's 1 times x squared minus 6 plus x minus 4 times 2x minus 0. So that gives us x squared minus 6 plus 2x squared minus 8x. So the derivative is 3x squared minus 8x minus 6. All right, another way you could have done it is simply by expanding to begin with and then taking the derivative. So if we expand this, we have x cubed minus 4x squared minus 6x plus 24. So then you can take the derivative and you would get 3x squared minus 8x minus 6 plus 0. Same thing. To find the slope, we just need to plug in x equals 2. So f prime of x equals 2 is 3 times 4, which is 12, minus 16 minus 6, which is negative 10. So that means we are looking for a point with slope negative 10 that goes through 2, 4. So we're going to use point slope form. Y minus 4 equals negative 10 times x minus 2. So y equals negative 10x plus 24. All right, find the derivative of this function. Trickiest part is probably just remembering what the derivative of secant is. So f prime of s equals 80s cubed plus 3 secant s tangent s, right? The derivative of secant is secant times tangent. So the answer is E. 31D, use product rule. So f prime of t equals 5t to the fourth cosine t plus t to the fifth times negative sine t, right? Derivative of sine is cosine, but derivative of cosine is negative sine. So simplifying this a little bit, we have t to the fourth cosine t minus t to the fifth sine t. Looks like that corresponds to choice D. All right, 32, we have to use quotient rule here, right? There is unfortunately no getting around it. We have to use quotient rule. And so dy dx, low d high, minus high d low over low squared. So 2x plus cosine x times derivative of sine, which is cosine, minus high d low sine x times 2 minus sine x, right? Because the derivative of 2x is 2 and the derivative of cosine is negative sine, all over low squared. All right, looks like it doesn't match anything yet, so let's simplify some more. Let's expand both terms. We have 2x cosine x plus cosine squared x minus 2 sine x plus sine squared x. Looks like that matches choice B. Oh, no? It does not, actually, because this sign here is different, isn't it? Okay, so it looks like we have to use an identity here. That's pretty tricky. So we have to use the fact that sine squared x plus cosine squared x equals 1, right? That's a trig identity you guys learned in pre-calculus. And so this actually simplifies to 1 plus 2x cosine x minus 2 sine x over 2x plus cosine x squared. And so that's the answer. All right, find the second derivative of this function. Well, I'm not going to use quotient rule because that will be super annoying. Instead, I'm going to simplify this into different powers, so I can use power rule. So if I divide each term in the numerator by x, I'll have 4x plus 5 minus 4 times x to the power of negative 1. So that tells me that the first derivative is 4 plus 0 minus 4 times negative 1, so plus 4 x to the negative 2. Now if I take another derivative, I'll be left with 0 plus negative 8 x to the power of negative 3, which is also negative 8 over x cubed. That's B. Question 34 now. Evaluate the derivative of this function at the point x equals 4. All right, so a fourth root means that I'm going to probably rewrite this as a power of 1/4 instead. So 4x cubed plus 5x to the power of 1/4. Okay, so here I'm going to have to use chain rule, right? Because I have a function on top of another. So I'm going to take the derivative of the outside function first. So that's 1/4, and I'm going to leave the inside alone. So 4x cubed plus 5x, and 1/4 minus 1 is negative 3/4. And then I'm going to multiply by the derivative of the inside function. All right, that's chain rule. So I have 12x squared plus 5. And then now I can plug in x equals 4, right? Because that's what I'm looking for, the derivative at x equals 4. So I'm going to plug in that, which will give me 1/4 times 256 plus 20 to the power of negative 3/4 times 16 times 12, 192 plus 5. Okay, so I'll have my final answer as 197 over 4 times 276 to the power of 3/4. Right? Negative 3/4 means I should take the reciprocal of a power 3/4. So it looks like that matches choice D. Next question. Find the derivative of this function. Right. First going to rewrite this so I don't have a square root. I prefer powers. So x to the 5th times 8 minus 7x to the power of 1/2. So I'm going to have to use both product rule and chain rule. All right, I'm going to use product rule first because I have a product of two different things. So that is going to be 5x to the 4th times 8 minus 7x to the 1/2 plus x to the 5th. And now I'm going to take the derivative of 8 minus 7x to the power of 1/2, which requires chain rule. So I'm first going to take the derivative of the outside function, which is that power of 1/2. So it's 1/2 times 8 minus 7x to the negative half. And then I'm going to multiply by the derivative of the inside, which is negative 7. Right? So this is actually pretty tricky to simplify. This is going to become 5x to the 4th square root 8 minus 7x minus 7x to the 5th over 2 over 2 square root 8 minus 7x, right? Because the power of negative half is 1 over the square root. And so now to simplify this, right, I would give you a lot of credit if you just wrote this and didn't simplify. But to actually get the full score, you need to see which one it matches up to. So that requires getting this under a common denominator. And so that would give us, if we multiply the first fraction here by the denominator of the second fraction, we're going to get 10x to the 4th times 8 minus 7x minus 7x to the 5th over 2 root 8 minus 7x. So that simplifies to 80x to the 4th minus 70x to the 5th minus 7x to the 5th. And then in the numerator, finally, we can factor out an x to the 4th. And we'll be left with 80 minus 77x over 2 root 8 minus 7x. And that matches choice D. Sorry, it does not match choice D. A. They look very similar, don't they? Yeah. Okay, so the simplification is the most tricky part, but getting product rule and chain rule right is also not easy. All right, some implicit differentiation. So we're going to take the derivative of both sides with respect to x. So d dx of 4xy equals d dx of 20. So if we take the derivative of the left side, we have to use product rule first. So it's going to be 4 times y plus 4x dy dx. Because remember that y is a function of x, and the right side is 0. So we're going to have 4x dy dx equals negative 4y, which means that dy dx is equal to negative y over x. And negative y over x is just negative 1/5 if we plug in those values. Okay, the trick for doing this a different way is simply by rewriting the original equation as 20 over 4x or 5 over x. And you can just directly take the derivative. You would get negative 5 over x squared, into which you can plug in those values. The value of x equals negative 5, you would also get negative 1/5. Next, implicit differentiation. So we're going to take the derivative of both sides with respect to x, remembering that y is a function of x, so we're going to get 2x plus 2, right? That's the derivative of these two terms here. And then as for the derivative of 3xy, that is going to be 3y plus 3x dy dx, right? To think about that, we've just split this up into two products, and we've used product rule. And then for y squared, we're going to have to use chain rule because we have a squared as the outside function, and the inside function is the y of x. So that's going to be 2y times dy dx equals 0. So if we combine those like terms, we're going to get that on the right-hand side, which means that dy dx equals negative 2x plus 2 plus 3y over 3x minus 2y. Does that match anything in the answers? No, not yet. So let's multiply top and bottom by -1. So we'll have 2x plus 2 plus 3y over 2y minus 3x. That's choice E. All right, last question on the multiple choice. The radius of a circle is decreasing at a rate of 3 centimeters per minute. So that tells us that dr dt is -3, right? Negative because it's decreasing, very important. And then what else do we know? We know that the radius is 4, so r equals 4, and we're trying to find the rate of change of the area, so that's dA dt. All right, so those are all the informations that were given. So let's now write a representative equation that relates these values. So that's the area formula for a circle, which is A equals pi r squared. And now we can take the derivative of both sides with respect to t, and we're going to get 2 pi r times dr dt. Right, I use chain rule there. So the derivative is 2 pi r, and then we have to multiply by dr dt. All right, so we're looking for dA dt, so we can just plug in those values we're given. 2 pi times r, which is 4, times dr dt, which is -3. And the answer is -24 pi. What are the units? Centimeters squared per minute. All right, so that's the last question on the MCQ. Let me go over the FRQ as well. So on the test, you are going to get these two questions pretty much identical, except I think some slight differences in the numbers. But the situation is exactly the same. It's the first question is cars approaching an intersection, and the second question is a kite being let out and it's rising vertically. So you'll get one of those two, all right? Depending on the version you have. All right, so the first situation, two cars are approaching the same intersection on perpendicular roads. So we have an intersection here, I suppose. So the intersection is here. So car A is here, and this guy's heading north at 40 miles per hour. And he's 0.3 miles south of the intersection. Car B is heading west at 25 miles per hour, and he is 0.4 miles east. All right, so that's the information. Let's use two different variables to represent the distances of the cars to the intersection. So let's use x here and y here. So y equals 0.3 and x equals 0.4. All right, and then what are we looking for? We're looking for how fast the distance between the two cars is changing. So that distance is given by that, right? So what are we given? We're given that car A is heading north at 40 miles per hour. So that means the distance between car A to the intersection is decreasing at 40 miles per hour. So that means dy dt, right? Y is that distance between the car and the intersection. Dy dt must be negative 40 miles per hour. And y is 0.3. Similarly, dx dt is negative 25 miles per hour, and x equals 0.4. All right. Let's call this distance between the cars, let's call that s, okay? And s squared equals x squared plus y squared. That's our Pythagorean theorem. And so what are we looking for? We're looking for how fast the distance between the two cars is changing. So to solve this, we're going to differentiate both sides of our equation with respect to time. And to do that, we're going to use chain rule. So the derivative of the left side is 2s times ds dt. And the derivative of the right side is 2x dx dt plus 2y dy dt. All right. So we're looking for ds dt, and we know x, we know dx dt, we know y, and we know dy dt. The only thing that we also still don't know is s. But the good news is that we can find s really easily from the Pythagorean theorem. It's just a 3, 4, 5 triangle, so s is 0.5. That means we can now plug in all our values. All right, so having plugged in all our values, this just simplifies to what does that come out to? Negative 20 minus 24. So ds dt is negative 44 miles per hour. All right. So on the free response, you're also going to have to write a short explanation. Now, I'm not going to do that right now because I want you to have your own words. But this does not need to be long. It just needs to be in complete sentences, but it doesn't need to really be like 500 words or anything. As long as your answer is clear and it makes sense and it's correct, you'll get full score. Clear, correct, and also in complete sentences. Okay, next one. A kite is flown so that a kite's string is being let out at 2 feet per second. And the person stays 20 feet horizontally from the point directly below the kite. So maybe this is my kite here. The person is 20 feet horizontally directly below the point from the kite. So this is 20 feet. And then the string length is 35 feet. And the kite is rising vertically. Okay, so the kite is going up vertically. There's no horizontal movement. In other words, this horizontal distance of 20 feet is staying exactly the same. All right, so let's call this variable, the hypotenuse, S, and let's call this vertical distance y. All right. So what are we given? We're given the fact that S equals 35, and we're also given the fact that the horizontal distance is 20. So we could say x equals 20. We also know that ds dt, right, how fast the string is being let out, is also 2 feet per second. So ds dt equals 2. We don't really need to call 20 any variable because it's staying the same, right? So we don't really care that much about it. And then what are we looking for? We're looking for how fast the kite is rising vertically. So we're looking for the rate of change of y. What is the equation relating s and y? It's going to be the Pythagorean theorem. So s squared equals 400 plus y squared. 400 is 20 squared. So we differentiate both sides, and we're going to get 2s ds dt equals, derivative of 400 is 0, so equals 2y dy dt. All right, so we're looking for dy dt, but something else is still missing, and that's the value of y. So we're going to have to use the Pythagorean theorem to find y first. Y equals square root of 35 squared minus 20 squared. 35 squared is 1225, if I remember correctly. And so y equals 1225 minus 400, which is 825. So square root of 825. Let me just check if that's correct. Yeah, and square root 825 is 5 root 33, so we could also write that. All right, so now we can plug everything in. So we have 2 times 35 times ds dt equals 2 times 5 root 33 equals dy dt. So that means dy dt equals 14 over root 33, or 14 root 33 over 33. Just check if I did my math right. Yep, which is approximately 2.44, what is it, feet per second. So that's the answer. And once again, you have to make some comments about this using some complete sentences. All right, that concludes this video. Good luck on the final. See you guys next time.